Thank you, Professor, for nice presentation. Question about Agre. If it's possible, few words about dynamic. Half-life, stability, dynamic during the cell cycles, and so on. Is it known something? If it is possible, some comment. Half-life.
Что вот это слово?
Half-life.
Half-life? Half-life. Ага. Half-life.
Degradation, half-life, and cell cycle dynamic, and so on. So, if it knows something about this one.
Sure. It's an important issue. And when we discovered the aquaforms, there was actually a paper published just before ours by our colleague Daniel Nathans, a wonderful molecular biologist, who identified the protein we know to be aquaform 1 is a delayed early response element, cultured fibroblasts. I think you're right. I think the regulation is modulated very rapidly and very carefully. I can't tell you specifically which cell type. Red cells, they live 120 days, the aquaform level pretty constant as far as we can tell. But they may well be involved in the cell cycle. I'm sorry, I don't know more than that.
Еще вопросы, пожалуйста. Вот вы говорили,
Thank you. Mr. Agre, well, just the other day I heard about a successful 3D printed rat kidney transplantation. And considering the complexity of such basic functions as water permeation as we've seen today, do you think, well, how do you think it is feasible for human bodily organs in 3D printed models for replacements like in the next decade?
Sure. So, if I understand the question, it's the idea of trans-species transplantation.
Well, yeah, like printing 3D bodily organs, is it feasible?
Sure. It's not something I know much about, frankly. It would be useful if we could manage the immune rejection to be able to use porcine organs or bovine organs. But these immunological barriers are still way too difficult. But that said, human-to-human transplantations can be pretty well managed with the current immunosuppressant medicines. So you never know what the future will bring.
Thank you.
I can say with confidence, it's not been done well yet, but it may be. Okay, last question.
Mr. Agre, I'm very glad for your visit in Moscow. Welcome to Moscow. Say, you are a modern, true scientist, true modern scientist. And what do you think about God? Are you believe in God or are you atheist?
It's a religious question. I was raised in the Lutheran Church. Most Scandinavians have a Lutheran affiliation. And I sort of have retained parts of this religious faith, not the belief in hereafter, I have no idea. But I think the notion shared by many religions that we should be doing God's work here on earth. Our work should have the benefit of others. And if this is a religious belief, that's great. If it's not a religious belief, that's also fine. So, I'm certainly not an atheist. I don't know enough. How would I know that there is no God? But I don't consider myself a born-again Christian. I respect the religion of other people. I personally feel that our works, our actions, should be how we judge rather than our statements of faith. That's a personal thought. Thank you.
Thank you. You don't mind. Okay, please.
I have a question connected with acropolis. You said that acropolis can be not in every cell in the organism, but some organisms, like can have both any acropolis. So, can you explain how it can be? So what will have propylene in the organism and some don't? And what are positive or negative factors to have or not to have propylene?
This is a question that is a little unclear about the importance of the null phenotype having no aquaporin expression. Is that your question?
Yeah, it's not
Sure.
only humans, I mean.
Okay, so the human null phenotypes have been identified for just a few members of the family. I talked about AQP1 null. It's very, very rare, but it doesn't seem to be physiologically so important unless one is fluid deprived. So I suspect while it's very rare, if it were harmless, it would not be so rare. So it probably has an important role in fluid absorption during birth. Aquaporin 2 mutants I talked about in the lecture, they actually have severe clinical consequences. It's lethal for mouse to have a knockout in aquaporin 2. It's a severe handicap for humans. Aquaporin 3 nulls have been identified, they've never been reported, but I can tell you they feel well. I think they probably have dysfunctional skin in terms of humidification barrier skin. No aquaporin 4 null individual has yet been identified. The knockout mice look okay, but they have a beneficial situation when there's sustained brain injury, yet they have decreased epileptic seizures. Aquaporin 5 appears to be mislocalized in some forms of Sjogren's syndrome. Aquaporin 7, I talked about the glycerol transport is delayed, but it's not a great clinical consequence. So overall, I have to say the aquaporins appear to be most important in times of stress, not in times of basal metabolism. Okay? Thank you.
Okay, we continue. Questions from you?
Professor, if I have read all right?
Or you tired? No?
Well, I'm all right. It's your program. I'm glad to participate as much. I don't get here that often.
So probably several questions.
Уважаемый профессор, у меня был вот такой вопрос. В науке происходит так. Сначала мы находим сложные вещества, а потом мы создаем новые направления, связанные с этими веществами. Может быть, сейчас стал вопрос уже о том, что вы создадите новые направления химии аквапарина. И второй вопрос такой. Существует в Америке издана книга, какая-то научно-популярная об аквапарине. И собирается ли издать такую книгу в нашей стране?
This is called I'm not planning to write a book about aquaporins in Russian or in English.
Так, еще?
Разрешите?
Пожалуйста.
Спасибо вам за замечательную лекцию. Это большая честь для нас слушать вас. Скажите, пожалуйста, уважаемый профессор, может ли плохой человек стать хорошим ученым?
Good question. Can a bad person become a good scientist? Well, there are many good people who are bad scientists or not scientists. So I think it's not an issue of human quality that determines science, it's inquisitiveness. And yes, personalities differ. There's some very unkind people I know in science who are successful. But I suspect young people have a choice of working in a successful lab with a kind mentor or a successful lab with an unkind mentor would prefer the kind mentor. So I think it's an infinite equality. I think truth, though, is important. A dishonest person will not be a good scientist because science is about the truth. Making a breakthrough in a prominent journal which is incorrect or fraud is self-defeating. So I think good qualities help.
Yeah. More questions? No questions. Oh, one, please.
Professor, if I recall right, you have a medical background, John Hopkins Hospital, yes, to practice. So as a young MD, I have a question for you. Would your MD help you in your scientific career, and what kind advice you would give to young medical degrees for medical doctors who want to pursue in the science? Thank you.
Sure. So I think the issue of medicine as a background for science is a very good one. I didn't do a PhD, I did an MD. And while I have maybe some limitations in my chemical, biochemical understandings, I can look things up, I can talk to others. But understanding the disease states was a huge advantage when we identified the different members of the aquaporin family, knowing exactly where they're expressed. We could anticipate physiological functions and pathophysiological defects. So I think medicine is a very good background for some forms of life sciences research, but it's not the only background. I think Steve already talked about recruiting young people with the pharmaceutical industry. They need people with lots of different backgrounds. And being a career medical doctor may not be of any preparatory value at all for information systems or structural biology. So it depends on the area of interest.
Okay, one of the last questions, if you don't mind. Yeah, please.
I think I'm taking the last one. I have a question. Okay.
After this gentleman, okay?
All right.
Please, no. You can, your question.
I'm the gentleman. Okay. I have a question to Professor Agre. Professor, after the winning the Nobel Prize, this prestigious award, what goals do you have after this? What projects you worked between 2003 and until now, and what you're going to do in the future?
Sure.
The future perspective.
Thank
you very much.
And I'm sure you are a gentleman. We had started working on malaria before the Nobel, and it became possible to focus all my attention on things that I couldn't focus on before. So the lab side focused entirely on malaria, but I've also got an increasing involvement in human rights, science diplomacy, but the lab side moving to malaria. And the Nobel made that easier. But I have to tell you, I don't think I'm a very successful malaria scientist. We have not made any important discoveries yet. Maybe as administrator for the institute will make discoveries. So there's no guarantee having a Nobel Prize that you do anything worthwhile later in your career. But maybe you can inspire others. Maybe that's the purpose of the event we have today, to encourage young scientists like yourself to go for it. You may make a brilliant discovery that will change the world. I hope you do.
Okay, and last, последний разговор. Да, последний вопрос.
As you had understood from your lecture, some proteins of the foreign family can transport glycerol. Yeah? And how do they do this without transporting water molecules at the same time?
So the question is very good. And we'd have to consult, I think, a molecular simulations expert like Klaus Schulten or Helmut Gugmiller to help us with that. It's not inherently obvious to me how glycerol moves with limitations on water, but in fact the structures support glycerol movement with the glycerol transporters, the aquaglycerol forms, and it may cause water to be spaced, but I'm sorry I don't have a better answer.
Okay, Professor Agre, thank you very, very much for your wonderful lecture. We had emotional and intellectual satisfaction this evening. Thank you very much. And I would like to thank also organizers of this event. And I'm very impressed with some questions. Thank you all of us for this wonderful time.